Okay, so these are going through some of the problems that were on our quiz. So the first problem on the quiz is 2x or x squared plus 2x minus 10 equals 0. This isn't an easy factoring problem, so we need to solve it either by completing the square or by using the quadratic formula. So I want to use the quadratic formula. And this right here is the quadratic formula. You'll have it on the test, but using it is not always straightforward. So we need to figure out, it says that x is negative b plus or minus the square root of b squared minus 4ac over 2a. So the first thing to do is figure out the a's, the b's, and the c's. So we want to be able to write this equation here in the form of some number a times x squared. So the number that multiplies the squared term is a. So a is 1. The number that multiplies the term that just has an x to the x that's not squared is b. So I have a b equals 2. And the number that doesn't have an x next to it is c. So c is negative 10. This doesn't seem to have been an issue for most people. So we've identified that a, b, and c are 1, 2, and negative 10. And now we need to plug it into this equation. So I'm going to say that x is negative b, that's negative 2, plus or minus the square root of b squared, 2 squared, minus 4 times a times c, that's negative 10. This whole term is divided by 2 times a, which is 1. So we have two solutions. We have the plus root, which is negative 2, plus the square root of 4. 2 squared is 4. 4 times 1 times negative 10 is 40. And we have two negatives, so they're going to cancel each other out. So this is plus 40. So we have the square root of 4 plus 40 divided by 2. 2 times 1 is 2. And our negative root is negative 2 minus the square root of 4 plus 40 divided by 2. So I'm going to simplify 4 plus 40 is 44. So negative 2 plus the square root of 44 divided by 2, or negative 2 minus the square root of 44 divided by 2. At this point, you are fine to put this in your calculator if you want, and get a decimal number for what the solution is to this problem. So plug that into your calculator, and you will get that the positive root here, x can be that, x is that. The positive root is 2.317. It goes on forever. Or the negative root is x minus the square root of 44 divided by 2, which is negative 4.317. Had you put that as your answer, you'd be right. I also, on the quiz, accepted these as correct answers, unsimplified. Where people went wrong on the quiz is in simplifying this. So let's talk about how you would simplify this. So if you wanted to further simplify this right here, so I have x is negative 2 plus the square root of 44 divided by 2. Here's what I can't do. I can't cross off 2 on the top and 2 on the bottom. Because this is, we need to be able to cross off a 2 everywhere in order to cross off a 2. So I could rewrite this as negative 2 divided by 2 plus the square root of 44 divided by 2. Then I can cancel my 2's here. 2 over 2 becomes 1, and this could be negative 1 plus or minus the square root of 44 divided by 2. That's true. We could even simplify this even further, which is I could write 44 is 4 times 11, and 4 here is a perfect square. So I could write that as negative 1 plus or minus the square root of, instead of writing 44, let's write this as 4 times 11 divided by 2. That's still true. So this is negative 1 plus or minus the square root of 2 squared times 11 divided by 2. And now I have a perfect square under the square root, so I can pull that out. So I could say that that equals negative 1 plus or minus 2 times the square root of 11 divided by 2. Somewhere around here, I added my plus. I turned my plus into a plus or minus. I meant to just be dealing with the positive root, but I'm so used to looking at this being a positive or a negative root. I'll go ahead and get rid of the pluses and the minuses and just keep it as a plus to keep this as straightforward as possible. So these are all pluses, not plus or minuses. So now I have a situation where I have a 2 in the numerator and a 2 in the denominator, and I can cancel it out. So my final, most simplified version of the answer to this, the positive root, is -1 plus the square root of 11. So this up here equals this down here. By the same logic, we could end up with another root, which is -1 minus the square root of 11. So this here equals this down here. What a lot of people did is they try to cancel out these 2's. You can't cancel out the 2 everywhere. You could cancel out the 2 here, but in order to cancel out the 2's everywhere, you need to get a 2 in every term, not just in one. So that's the first problem. Our second problem was another equation that can't be easily factored, so we're going to use the quadratic formula again. And use the same equation again. So now I have that A is the number that multiplies the squared term, so that is 1 again. B is 8, and C is 10. And I want to use that X is B plus or minus the square root of B squared minus 4AC divided by 2A. So if I write this, plug A, B, and C, I have that a positive root and a negative root, which is my positive root is X is 8 plus the square root of 8 squared minus 4 times 1 times 10. All of that divided by 2 times 1. My negative root is X minus 8 squared minus 4 times 1 times 10 divided by 2 times 1. That's my 1 over here. So those are my 2 roots. I'll make sure that it's really clear that everything here is in the numerator. So I'm going to simplify this. I'll work on the plus root side. So I'll have X is 8 plus 8 squared is 64 minus 4 times 1 times 10. 4 times 1 times 10 is 40. So this is going to be 64 minus 40 divided by 2. That becomes 8 plus 64 minus 40 is 24 divided by 2. And at this point, you are fine plugging this into your calculator and getting that X is, well, I made a mistake. And it was in how I wrote the quadratic equation. This is negative B, and if you look back here, that is what we did on the first problem, but I dropped my negative in that equation. So X is negative B, which means that this is -8, and -8, and -8, and -8. So if I plug -8 plus the square root of 24, push enter in my calculator, divide that whole thing by 2, I get that X is -1.551. And that is the answer. You're welcome to just plug that number into your calculator and box that as your answer, and that's fine. To continue simplifying this, though, let's keep going. I'll do it a slightly different way this time, just so you can see 2 different ways. So let's do X is -8 plus the square root of 24. 24 is 6 times 4. So this is square root of 6 times 4 divided by 2. And the reason that I've written this out as this way is because 4 here is a perfect square. 2 squared equals 4. So I can keep going and say that X is -8 plus 2 squared times 6 divided by 2. And now I have some number squared underneath the square root. That just ends up being the number. So X is -8 plus 2 times the square root of 6 divided by 2. And now I have a situation where I can cancel some things. So 2 divides evenly by 2. 8 divides evenly by 4. So if I'm going to take a 2 out of everything, I could call that a 1, call this a 1, and call that a negative 4. And I would end up with x is negative 4 plus the square root of 6. All of that is divided by 1, but of course any number divided by 1 is just the number. So in my end, I end up with x is negative 4 plus the square root of 6, which equals this number, equals negative 1.551. So lots of algebra errors were made in the attempted simplification of some of these radicals. By the same logic, the only thing that is different here is this negative. So this plus would become a negative, this plus becomes a negative. We can go all the way down here and we'd end up with x equals negative 4 minus the square root of 6. And that number equals negative 6.449 as our 2 answers, the 2 roots to this problem. So that is simplifying the quadratic formula. The next problem on the quiz was an equation that said x plus 4 is less than or equal to 2, and I asked you for interval notation. And a number line. So we're looking for what number plus 4 is less than or equal to 2. So we're going to solve this the way that we would solve any equation without the less than or equal to sign. So we're going to subtract 4 from both sides, and the 4's cancel, and I have 2 minus 4. So this becomes x is less than or equal to negative 2. A bunch of you said things like x is less than or equal to negative 2, or x is greater than or equal to 2, or something like that. We're not doing that yet. You only do those, split it up into 2 different things when there's absolute values in the equation. So we're not doing that. We just have an equation that says x is less than or equal to negative 2. In interval notation, this is that x could be as low as negative infinity or as high as 2. It could include the number 2. So whenever it can include that number, we use a square bracket. So this is the interval notation. That's the answer for the interval notation. So whenever we have an infinity here, we always use a curved bracket. And we use a square bracket when we have a less than or equal to sign or a greater than or equal to sign. Oh, and that should not be a 2. It should be a negative 2. So on my number line, I'll go 0, negative 1, and negative 2. I'm going to put a closed dot because the number 2 is one of the possible solutions, right? Negative 2 is less than or equal to negative 2, so it's a closed dot. And I'm looking for all the numbers to the left. The left then sign points in an arrow to the left, so we're going to fill in everything that points in it that is to the left of negative 2. So here's my interval notation, and here's my number line. So those are the 2 things that needed to be in my answer. The next question, question 4, said 2x plus 4 is greater than 3x minus 1. And now we need to solve this again and treat it as though this is a this greater than sign is just an equal sign. The only thing that we have to remember in this equation is that if we multiply or divide by a negative 1, then we have to flip the sign of the inequality. Otherwise, we treat this the same as we would treat any equal sign. So if we want to solve for x, let's get all the x's to one side and all of the not x's to the other side and solve it from there. So I'll pull the x's to the left, so I'll go minus 3x on both sides so it can get rid of that. And I will go minus 4 on both sides so we can get rid of that. And we end up with 2x minus 3x, that's negative x, is greater than negative 5. And now if we want to get this to be a positive x, we're going to make the negative of both of them. So if we wanted this to become x and a positive 5, that's when we have to flip the sign of the inequality. So instead of the greater than sign, this becomes a less than sign. So x is less than 5 is the answer to this question. In interval notation, that is that we're going to start at 5 and we're going to go down to negative infinity. So all the numbers that are less than 5 are to the left of infinity. And because this is not an equals, a less than or equals to, it's just a less than, the number 5 doesn't work here. 5 is not less than 5. So it doesn't include 5. Because it doesn't include 5, we use the curved parentheses instead of the square bracket. So that's our interval notation answer. And our number line is 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. We have an open circle because 5 is not one of the possible solutions. And our arrow points to the left. Okay. So that's number 4. The last question was an absolute value inequality. So I had 5 was the absolute value of 2x plus 4 is greater than 1. This is where that less is nest, more is or notation came from. So I have a greater than sign. So because it's a greater than sign, I'm going to say more is or. So I need to break this up into 2 different inequalities and say that 2x plus 4 is greater than 1, or because it's more, it becomes an or. If this was a less than sign, I would be saying and here, but it's a greater than sign, so I'm saying or. 2x plus 4 is now less than negative 1. So there's 2 things I had to change here, and several of you missed this. The greater than sign became a less than sign. That flipped. And the positive 1 became a negative 1. So I need to solve this equation separately from this equation, and I will have 2 different values of x. X can be this one, or x can be this one. And that's going to be the solution to my inequality. So I'll start on the left. I'm going to solve for x, so I'll subtract 4 on both sides. That'll get rid of my 4's, and I have 2x is greater than 1 minus 4. That's negative 3. Now divide both sides by 2, and I have that x is greater than negative 3 halves. On the other side, I'm going to subtract 4 from both sides. That'll get rid of that. And I'll have 2x is less than negative 1 minus 4. That's negative 5. Now I can divide by 2 on both sides. And I have that x is less than negative 5 halves. So my answer is that x is greater than negative 3 halves, or x is less than negative 5 halves. So let's plot this on a number line. Here's 0. These are all negative numbers, so I'll go negative 1, negative 2, negative 3. Negative 3 halves, that's 1 1/2. Plug it into your calculator if you don't like the fractions. 3 divided by 2 is 1.5. So right here, I'm going to put an open circle because there's no equal than sign here. It's just greater than at negative 3 halves. And it says that x is greater than negative 3 halves. So we're looking for all of the numbers on the number line that are bigger than 3 halves. On our left-hand side, x is less than negative 5 halves. 5 divided by 2 is 2 1/2. So this is x is less than negative 2 1/2. Here's negative 2 1/2. I'll put an open circle again because it's a less than, not a less than or equal to. And now I want to cover in all of the numbers that are less than this number, so all the numbers to the left of it. And it looks like that. Okay, this is my solution. It can be greater than negative 3 halves, less than negative 2 halves. To write that out in set notation, in interval notation, I have this part here, which starts at negative infinity and goes up to negative 3 halves, or negative 5 halves. And it would have curved on everything because I have an open circle. Open circle goes with the curved. And then this one up here starts at negative 3 halves, so negative 3 halves, and it goes up into infinity. And where we have a or, we write the U for the union. That's the solution for this problem. So remember this. We only split it into two equations when there is an absolute value. We don't split it into two equations when there's no absolute value. And because there is a greater than sign, we're going to end up with an or. And whenever we're solving the ors, we end up with the arrows that point out in opposite directions. So we always end up with something that looks like that. So more is or. If this was a less than sign, if we were solving an equation that had, I'm going to make something up that may or may not work, but if this was a less than sign, we would be saying less. If this was a less than sign, we would not be saying more is or. We would be saying less is nest. And we would be writing an and right here. And instead of our number line being arrows pointing out, I think actually if we did this one, we would have no solution because no number is both greater than negative 3 halves and less than 5 halves. But if we had a solution that worked, the nest, why we say nest, is because our shading in the number line would end up being something that's shaded between the two answers. But that's not what this one was. There are there's one in particular YouTube video that I posted about absolute value inequalities that is really good. So if you're struggling with absolute value inequalities, check that one out and kind of get some practice from the ones that he is doing. I would encourage you, see the problem that the person is going to do, and then try to work it on your own, and only go forward when you get stuck or when you need to check your answer so that you can get some actual practice rather than just watching him solve a problem. Okay, so that's all of the answers on the